name's Mike Allen. I'm the Managing Director of Nuflow Tasman. We were approached by the Nelson City Council in February of last year to propose a solution to rehabilitating the historic brick barrel stormwater line that runs from Collingwood Street to Trafalgar Street. So 250 metres, it was laid in 1860. So the solution we offered was a Impreg GL16 UV liner. It's a glass reinforced liner that's made up of corrosion resistant glass that comes pre-impregnated with thermo-setting resins. A feasibility study was carried out with 4 different options for either renewing or relaying the existing brick barrel stormwater line. The GL16 liner option ended up being the chosen option. The benefits of a UV liner over a complete replacement is there's minimal environmental impact. There's absolutely zero excavations required for it. We're utilising the existing manholes at either end, as well as a central manhole for feeding in the light train and the liner. So from that feasibility study, the liner option was chosen. So fast forward to October last year, and we went into the preliminary investigation stage where we did a end-to-end CCTV to ascertain the condition of the line. What we found was structurally it was still intact, but certainly had some signs of wear and tear with some bricks missing, some mortar and grout. So from there, what we've done is we've gone through end to end, doing a full clean and flush of the line, followed by a hydrovac. That allowed us to remove all the existing silt and debris from the line. I think in total, over the 2 visits, we removed around 20 tonne of silt from the line. After that, we've done our final CCTV. We've done a measure 9 different locations. That's allowed us to check the overall circumference of the line and ensure we've got consistency along the length of the line. Okay, so the last 2 weeks we've moved to the installation phase of the project. Last week was about final flush of the line and CCTV. We'd had some downtime between when we'd originally done the clean and the measure, so we just need to ensure there was no additional debris, loose bricks and silt. We've gone through and done that final flush of the line, final CCTV in preparation for the installation this week. We've then gone through and installed glide foil from end to end, which allows us to feed the liner into position and have a nice smooth frictionless surface to avoid any damage of that liner as it gets pulled into the line. So the installation's been broken into 3 sections. The reason for that is one of the sections is actually a mortared section of brick barrel, so it's a slightly different internal diameter. So we've broken it into 3 runs. We've got 130 metre section, approximately 60 metre section, and then about a 55 metre section for the last shot. So we've broken it down into 3 shots, all fed from a central manhole with rollers installed at both ends to ensure a smooth installation.
I'm James Holler. I'm the Business Development Manager and Technical for Nuflow Australasia. After installing that glide foil, what we then do is then pull that liner into place. The line is pretty heavy, especially with that size and the meterage. So what we need to use is a winch. So we have a trailer winch up the top end. So then we're winching that liner from one end to the other, where both of the liner ends are actually protruding out the ends of the pipe. We'll then go and install these end cans. These end cans are actually going to keep all the air inside the pipe and allow us to inflate that liner to a working pressure. Once we have the liner inflated a little, we actually need to then insert that light train into the liner itself. The light train is going to be used to be carrying the liner. And then we start actually doing what we call a calibration process. So we're actually inflating the liner 30 millibar every 5 minutes up to working pressure. With this liner, this diameter, we're actually inflating up to 250 millibar. The reason why we actually inflate at 30 millibar every 5 minutes is just going to allow all those layers to nicely compress to the hose pipe. Any sort of shortcuts that are being made or anything like that, what's going to happen is not going to perfectly form to the pipe, and then you'll have delamination through the layers of the liner. Once we finish the calibration process, we're actually going to pull that light train from one end to the other. During this process, we're actually inspecting the internal wall of the liner to make sure there's no wrinkles or any defects inside the line while we're actually pulling it from one end to the other. So what we're using is a dual light core from Procasero. Each light core has 4 1000 watt bulbs, totaling of 8 1000 watt bulbs. Each of these bulbs emit a certain UV wavelength of light, allowing us to cure the liner at 0.6 meters to 0.8 meters a minute. So before we actually cure the liner, we actually need to go through an ignition process with each of the bulbs. So we turn the light core on one at a time, allowing the lights to actually go to full intensity. So we're actually getting best results for curing. Once all the bulbs are actually on, then we're actually pulling that light core back at a calibrated speed of that 0.6 to 0.8 meters a minute. So while that light train is being pulled through, the liner is being cured. It's fully hardening from a soft, malleable state to a fully solid state. Once we get that light train to the other end, then we'll go through and then turn those lights off and allow the liner to cool down before we start pulling off those end cans. We'll then remove the light cores out of the pipe. Go through and cut those ends back nice and close to the head wall, and then we'll seal those ends with a mortar. This is just another great example of what pipe rehabilitation can do compared to traditional replacement. Less disruption to residents, traffic, business owners, and the cost benefits are significant.
I'm Senna from Isaac Construction, and I work as a site engineer for this brick barrel UV lining works. This project uses an innovative technology that helps us avoid a large amount of trenching work, significantly short construction period, and reduces the impact on stakeholders. It also delivers cost savings for the client. It has been great working with Mike and his team from Nuflow Tasman, who understands our requirements and works collaboratively within our timeframes to help deliver the project. We're very proud to be part of this Bridge to Better project.